इधर उसी ऑफिस पे ले जाओ, मैं उधर ही आ रहा हूँ।
All right, assalamu alaikum everyone. Let's start. So in our today's session, we are going to do inverse normal. Just give me a minute. Let's start. All right, let's begin. So we started normal distribution a couple of days ago, and we talked about some basics. In the last session, we discussed how to find probabilities using the table given that a variable follows normal distribution. So how do we calculate probabilities? The first thing we do is we use this formula z equals x minus mu over sigma to convert whatever we have to z first of all. Once we have converted that to this form, we use the table to find probabilities. However, for the table, we need to have a form that looks like this first of all. Probability of z less than a positive number. Once we have converted our expression, our probability to this form, we use the table and find the probability. If we don't have this form, we have to convert it to this form. We discussed a number of different cases that we would have to deal with in that case. And we discussed how do you find probabilities in each of those different cases. All right, so that's what we did in our last session. And we also did a practice question from the worksheet. So this was one concept that you need to know about in normal distribution, that if you have some data given, how can you find probabilities using the table? All right, that's what we did in our last session. Now today, what we're going to do is we are going to do the reverse process and understand how that works. This is called inverse normal. Now, in this case, what's going to happen is we would have some variable which follows normal distribution. However, we would have some missing information. So for example, we might not know what the mean is, or we might not know what the standard deviation is, and we would have to find those values of mean and standard deviation. So for instance, you might have something like this. Let's say you have a variable x, and this variable x follows normal distribution. And it's such that the mean is 54 and the variance is sigma square. Now, what does that mean? That means Mu is 54, so we know the value of mu. However, we don't know what the variance is, and we also don't know what the standard deviation is. And we want to figure out now is we want to figure out the value of sigma, the value of the standard deviation that we have in this case. We want to figure that out. All right, so we want to find out what the standard deviation is. Now, for this, what they will do is they'll give you some probability. So, for example, let's say they tell you that the probability of x being less than 60 is equal to 0.7024, let's say. This is what we're given. That the probability of x being less than 60 is 0.7024. And what we want to do now is we want to find the value of sigma somehow, right? So that's some missing piece of information in the data that we have to figure out. Now, how do we work this out? For this, what we are going to need to do is we are going to use we are basically going to go in reverse order. So we have a probability given. And we have to go back and find something that's missing in the data. Now, for this, what you would need to do is you would need to read the table in the reverse order. So remember this normal distribution table that you have? Until now, what we've been doing is we have been using the values of z to find probability. So we used to look at a value here in the first column or the first row, and then find corresponding probabilities based on that, like this, right? Now we're going to go in reverse order. So we have some probability given, and we would have to find the corresponding z value from that. That's the idea. So you would have some probability given, we would have to find the corresponding z value from that. Now remember how the table is structured. You have z values in this first row and in this first column. So we discussed the structure earlier. It looks something like this. So we're going to have to use this table instead. It has the regions colored. It might help understand better. Let's going to use this version. Just erase everything else from here. Okay, so this is the table that we have. We know how to use it in the normal order, which is that we have the value of z and we want to find some probability. For that, we can use this table like this. That we read what the value of z is, what the value of probability is for a certain value of z. Now this region here, all of this region, so let me ask you, like this, all of this region, this represents probabilities, all right? So now what you would have is, you would have, what you would have would be that you would have a probability given. For example, in this case, it's 0.7024. You have this probability given, and you would have to find the corresponding z value for that. Let's learn, first of all, how to read the table in this direction. Let's say we have a probability given like this. Let's say the probability is equal to 0.8810. And we want to find the corresponding z value for this. All right, so now we know what the probability is. We want to find the corresponding z value for this. Now remember, probabilities are given in this region, all of this region. So what we have to do is we have to go to the table and look for this value and see where 0.8810 is in this table. Let's find that value out. Now for this, I would recommend that you have the table in front of you. It's given in the formula sheet. So it's better to have a printed copy of that if you can have it. So this is how the table looks like. We have to look for this probability value. Now you don't have to search for it randomly. The values are actually sorted in this table. So the probabilities are increasing from left to right like this, and also from top to down. Okay, so the probability values are increasing left to right and top to down. So they're all in order. So it's not going to be that difficult to search for this value. 0.8810, let's see where that is. 0.8810. This is where we have 0.8810. This is the probability value. And now what we do is we read the corresponding Z value for that. It's 1.1 on this axis, and then 8 here. So what's the value of Z that we get from this? It's 1.18. That's the corresponding Z value for this value of probability. All right. So if we had this probability given, this is how you read that value from the table. Let's take another value. Let's take another value of probability. So this was easier because we got exactly that value from the table. But you can have cases where you can't find the exact value in the table. So for example, let's say if you have a probability given like this. Now, let me take another example. Let's say you have 0.8294. Let's say you have something like this, 0.8294. Now let's search for this value. Let's see where this value is. Now we go around searching for this value, and we find that we have 8289 here. And then after that, you have 8315. Where is 8294 going to be? 8294 is going to come between these two values, right here. What you do in such a cases where you can't find the exact probability value in the table, you take the smaller value. So it's 0.8294. What you do is you take the value that's immediately smaller than this, and that's 0.8289. So you take this value from the table, 0.8289. Now, what's the corresponding Z value for this? 0.95. So that is going to give you the first two decimal places of the Z value, 0.9 and 5. Let's see what that is. So let's write that down here, 0.95. However, the probability that we were looking for was 0.8294, and what we have found in the table is 0.8289. Now, let's write that down here. 0.8294 is what we were looking for. What we have found from the table is 0.8289. What's the difference? How much more do we have to add to 0.8289 to get 0.8294? We need 5 more at the end, right? So remember the third decimal place for Z used to give us a value that we have to add to the probability. Now, this is the value that we need to add, 5. So what we do now is we go in this row on the right side and see where 5 is. You've got 5 here. So you say the corresponding value for Z that you get here is 2. So that is what you need to have as the third decimal place of Z here. So the value of Z therefore turns out to be 0.952. That's the value of Z that you have. Okay. So if you can't find the exact value from the table, what you do is you take the smaller value, the value that's immediately smaller than this. So that's 0.8289 here. You get the first and second decimal place of Z from that, which were 0.95 in this case. And then you see how much more do you need to add to this value. So 0.8289. If you add 5 to the last digit here, that would give you 8294. And that gives you the third decimal place of Z, which is 2. All right, let's take another example. Let's say you had something like this instead. Let's say you have probability given, which looks like this. It's, let's say, 0.7498. Let's say we have something like this, 0.7498. Now again, let's go to the table and search for this value, see where this turns out to be. 0.7498. Now, can we find this value? Let me get rid of what we've done before. It becomes cleaner. Okay. 0.7498, can we find that value? 7498. We have 7486 here. And then the next value is bigger. So we take the smaller value. So 7498 is going to come somewhere here. So we take the value that's immediately to the left of that. That's 0.7486. Now, what value of z do we get from this? 0.67. These are the first two decimal places. So we say z equals 0.67 first of all. Okay. Now let's write that probability down here. The probability that we are looking for is 0.7498. What we have found from the table is 0.7486. Now, how much more do we have to add here? Let's find the difference. We need 1, 2 at the end. And at the last two decimal places, we need 1, 2 more, 12 more. So now we go on the right to the right side here and see where 12 is. We want 12 more, right? Now, do we have 12 anywhere here? We don't. However, 12 is going to be between 10 and 13 here. So 12 is going to be somewhere here. Now what you do in this case is, if you can't find the exact value for the third decimal place here, you see which value is 12 closer to. 12 is closer to 13. So what you do here is you choose the value that corresponds to 13. You choose 13 here. If you have to choose between 10 and 13, 12 is closer to 13 as compared to 10. So that's why you choose 13. Now, corresponding to 13, the value of z that we are getting is 4. So we write 4 here. Z turns out to be 0.674 for us. All right, so that's the value of z that we get from this. Let's take another example. Let's say we have a probability given that looks like this. Let's say this one is 0.6684. Yeah, let's say we have something like this. For probability is 0.6684. Again, we need to find the value of z corresponding to this. How do you figure this out? Let's search for this value in the table. 0.6684. Where is that? So 0.6684. It's going to be somewhere here between these two values. What we do is we take the smaller value, which is 0.6664. This is the value that we take from this. What's the value of z that we're getting? 0.43. The first two decimal places are 0.43. Now, the probability that we were looking for was 0.6684. What we have found from the table is 0.6664. What's the difference? 20. So we need to add 20 more to this value to get the probability that we need. Now, let's go to the right side here and see where 20 comes. So we go all the way to the right side here and look for 20. Well, again, we don't have 20 here. 20 is going to be between 18 and 22. All right, it's going to be somewhere between them. Now, since we don't have exactly 20, what we think about is what value is 20 closer to? Is 20 closer to 18 or 22? Well, it turns out it's the same distance from both values. 18 and 22 both are at an equal distance from 20. So what do we do in this case? When it's exactly in the middle like this, you choose any one of these two values. You either choose 18 or 22, it doesn't matter. So you choose any one of the two. So you can either have 5 here or 6 here, both will be acceptable. So you could write that Z is 0.435, and that's okay. Or you could write that Z is 0.436, that is also okay. Or you could also say it's between the two. So that would be 0.4355. That is also okay. So in the marking scheme, you'll see they would have given both of these values. But even if you were to use this one, that's also fine. You can use any one of these three. All right. So if it's exactly in the middle there, you choose any one of those two values, and that will give you the corresponding value for Z. All right. So that's how you read the table in the reverse direction. So if you have probability given and you have to find something, you have to find the corresponding value for Z, this is how you read the table in the inverse direction. So we need to use this for the inverse normal. So now that we know how to read the table, let's go back to the example that we were looking at. So this was the case that we had here. We had a variable X that was normally distributed such that the mean was 54 and the variance was unknown. We had to find the standard deviation for this. Now, how do we approach this problem? First of all, we have something in this form, probability of X less than 60. That is given to be 0.7084. Now remember, we don't have X in the table, we have Z in the table. So the first thing we do is write this in terms of Z first of all. So we say this corresponds to probability of Z less than something that we do not know yet. That is equal to 0.7024. So the first thing you do is you convert that probability to something in terms of Z instead. All right, it's converted to something in terms of Z instead. And now you need to find this value of Z. You need to figure out what this value of Z is. Once you figure that out, after that, you could just use that formula, Z equals X minus mu over sigma, to find whatever unknown you have to figure out. But that's to come later. Let's focus on this for now. So the first thing we do is we write the probability in terms of Z, and we need to figure out this value of Z. Now, how do you figure out this value of Z? The first thing you need to do is you need to convert it to the standard form, right? Remember, we can only use the table if the probability is in standard form. What's the standard form? Remember, the standard form looks like this. Probability of Z less than a positive number. That's the standard form that you have for normal distribution. In order to use the table, you need your probability in this form. Now we have a less than sign here, and that's okay. But the problem is we do not know whether this value here is positive or negative. So we need to make sure that this is positive. If it's not positive, we'll have to convert it in a form that it becomes positive. Let's figure out, first of all, whether this value is positive or not. And we do that using the normal distribution curve. So we think of the normal distribution curve. This is what the curve looks like. Now, what does this statement mean? Probability of Z less than something, that is equal to 0.7024. The first thing you have to figure out is whether this value here is positive or negative. Whether the value of Z here is positive or negative. How do you do that? This statement means that the probability to the left, so this less than sign means that the probability to the left of this value of Z is 0.7024. Now think about it. The total probability under this curve is 1, right? So 0.5 on the left side, 0.5 on the right side. The total probability is 1. Now 0.7024 is a major part of that probability. So out of 1, 0.7 is a relatively big number. So generally what we do is we compare it with 0.5 to figure out whether the probability is big or small. So what we say is 0.7024, this is a value that is bigger or greater than 0.5. This value is bigger than 0.5. Now think about it. Z could come either on the left side here of this curve or on the right side here. Remember, 0 is in the middle, you have 0 because the mean of this distribution where you have Z is 0. So at the center, you have 0 like this. Now, Z could either be on the right side, that means Z could either be positive, or it could be on the left side, that means it could be negative. It could be on any one of these two sides. We need to figure out whether it is on the right side, that means whether it's positive or negative, whether it's on the positive side or on the negative side. We have 0 in the middle. What we're saying is, wherever Z is, to the left of it, the area should be bigger than 0.5. The area to the left of Z should be bigger than 0.5. Now, if we place Z here, if we say this is Z for us, now what's the area to the left side of this? Is this bigger area or smaller area? If you compare it with 0.5, this area, the yellow region, it's actually less than 0.5. Okay, we want the area to be bigger than 0.5. So Z cannot be here. On the other hand, if you were to place Z on the other side, that's here. If you were to place Z here, what about the area to the left of Z now? This area is bigger than 0.5. The area to the left of Z now, in this case, is bigger than 0.5, and that's exactly what we want. So that means Z should be on the positive side. So Z should be somewhere here. This is where Z has to be, because only then you can have the area to the left of Z greater than 0.5. All right. If you were to place Z on the left side, the area to the left of Z would be less than 0.5. We need it to be bigger than 0.5. Okay. So that tells us that the value of Z that we have is supposed to be positive. So this number is a positive number. So that's what we have figured out. Now we know that the value of Z is positive. So we have a less than sign. And we know that Z is positive. So that means we have the standard form. We have a less than sign and a positive number here. This is the standard form. We can read this value from the table. We can go to the table and figure out the value of Z corresponding to 0.7024. Let's go to the table and find that value. 0.7024, that's the probability. Let's look for 0.7024 here. So remember 0.7024, that is what the probability is. Now we don't have 0.7024 here, but we have 0.7019. Let's see the value corresponding to that, 0.53. So the value of Z that we have corresponding to this is 0.53. But then we were looking for 0.7024. What we have found from the table is 7019. What's the difference? How much more do we have to add to it? 5 more. We go to the right side here and see where 5 is. 5 is going to be somewhere here in the middle of 3 and 7. Now it's exactly in the middle, right? It's not closer to either 3 or 7. What we say is you can choose any one of the two. You either choose 3 or 7, it doesn't matter. So let's say if we choose 3, the corresponding value that we get here is 1. So we have 0.531. Okay. So you could choose any one of the two, 531, 532, or even 5315. That's your choice. So that's the value of Z that I'm getting, 0.531. Let's get back to this now. This means Z is 0.531. And remember, we know that this is a positive number. Z is a positive number. So you have to keep it positive like this. You have found the value of Z. Once you have found the value of Z, now you use the formula. This is what the formula looks like. Z equals X minus mu over sigma, right? Just input values in this now. What's the value of Z? Z is 0.531. What's the value of X? The corresponding value for X that corresponds to this value of Z is 60. 60 minus the mean mean is 54. We know that. Divided by sigma, we have to find that value. Sigma is something that we need to figure out. Now we just evaluate sigma from this. So that's 6 over 5.31. That's going to give us the value of sigma. Let's see what this turns out to be. 6 over 5.531. This is giving me 11.3. And that's the standard deviation that we were looking for. All right. This is how inverse normal works. This is how we figure out something that's missing from the data if we have the probability given. All right. This is how inverse normal works. Okay. Now let's look at a few other examples. In this case, we already had the standard form. We knew that Z is something positive, and we know that the area to the left of that is how much? This area is 0.7024. It was already the standard form. We could use the table for this directly. But what if it's not already the standard form and you have to convert it to standard form? First, let's take a few examples of that to see how we would deal with all of those different cases. So we could have, for instance, probability of X greater than 62 in a case. All right, let's say we have something like this. And this is equal to 0.2357 maybe, something like this. All right. Now, we need to figure out something missing from the data. All right. So the key here is we need to find the value of Z first of all, what Z is. Once we have the value of Z, we can just use the formula Z equals X minus mu over sigma to find any unknowns that we have. We might have X missing or mu missing, or X is in fact known here. We might have mu missing or sigma missing. We can find those values. Okay. Using that formula at the end. The first thing that we need to do is we need to figure out the value of Z that corresponding to 62. Now, how do we start with this? First of all, we do the same thing that we did before. We convert it to something in terms of Z. So it becomes, instead of X greater than 62, we say it's Z greater than some value, which we have to figure out, that is equal to 0.2357. All right. So we first convert it to something in terms of Z like this. Just replace X with Z. And on the right side, you have this box that represents that you could have any number here. We have to figure that out here. Now we need to figure out whether Z is positive, whether this value is positive or negative. Because in order to be able to use the table, we want this form. If we don't have this form, we can't use the table. Now, again, how do we think about it? We can think of the normal distribution curve. This is how the curve looks like. Now we think of this using the curve again. It says probability of Z greater than this value. That means to the right of this value, area to the right. So if you want, you can write that here. You can say this stands for right. So area towards right of this value. How much is that? This value, if you compare it with 0.5, is it less than 0.5 or greater than 0.5? It's less than 0.5. So we say this is a smaller area. So this is smaller than 0.5. So what we have here is that the area to the right of Z should be smaller than 0.5. Right? Now, where do we place Z? If we place Z here, what's the area to the right here? Is it bigger than 0.5 or smaller than 0.5? It's bigger than 0.5, right? Area to the right here would be bigger than 0.5. So we can't place Z here on this side. If we place Z on the right side, area to the right of it is smaller than 0.5. And that's exactly what we want So Z should be placed here. That means Z is on the positive side. So the value of Z that we have here is positive. It's a positive value of Z. All right. And we are given that this region, this area, how much is this? This area is 0.2357. So we know that the value of Z is positive. Keep in mind, this is going to be important at the end. The value of Z that we have is positive. But do we have the standard form yet? What's the standard form? The standard form that we can use the table for is Z less than positive. We have a positive number here, yes, but we have a greater than sign. So we have to convert it to something in the form less than something, okay? So we convert it to probability of Z less than this value of Z. Now think about it. If the area to the right is 0.2357, what about the area to the left of this value? That would be 1 minus this. So probability of Z less than this positive value of Z, what is that? That's 1 minus 0.2357. So this area is 1 minus 0.2357. Let's evaluate that. That turns out to be 0.7643. Now we have the standard form. When we have the standard form, we can use the table to find the corresponding value for Z. So now we can use the table. All right, let's use the table and figure out the value of Z corresponding to this value. All right, let's go to the table now and find the corresponding value of Z for this probability, 0.7643. This is the probability that we have, right? Now, let's find that here. 7643, we have 7642 here. Okay, so that gives us 0.72 as the first two decimal places. Z is 0.72. And then we have 0.7643. That's what we were looking for. What we have found from the table is 7642. How much more do we need to add? We need to add 1 at the end. Now let's go to the right side here and see where 1 is. Well, there's no 1 here, but it's going to be to the left of 3. So what is the third decimal place that we take here in this case? You see, if you had to add 3, you would say the value of Z here, the third decimal place of Z should be 1. What if the third decimal place of Z was 0? In case of 0, you would not be adding anything. If the third decimal place was 0, you would not be adding anything. So you can think of it like this, that yes, this value is 3, but if the third decimal place was 0, you would not be adding anything. 1 is coming between them. 1 is coming between 0 and 3. Is 1 closer to 0 or 3? 1 is closer to 0. So the third decimal place that you have here should actually be 0 instead of 1. So you have 720 here. All right, because 1 is closer to 0 as compared to 3. So if the third decimal place was 0, you would be adding nothing. So you add nothing in this case. All right, so that's 0.720. That's the value of Z that you have. Write that here. You say that the value of Z that you get here is 0.720. You know that this value was supposed to be positive, so that's 720. Now you can just input this value in the formula to find any unknowns that you have. So Z equals X minus mu over sigma. That's the formula. You can just input this value of Z here, 0.720. And any unknown that you have here on the right side, you can find that from this equation then. All right. So that's And that's another possibility that you could have. You have area to the right here given, and you have to find this using this logic. All right. Let's take another example. Let's take another example. And now let's see. Let's say we have something like this. Probability of x greater than 50. Let's say we know that the probability of x greater than 50 is equal to 0.7253. Okay, so now we have this probability. X greater than 50, this is 0.7253. How do we think about this? Again, the first step is going to be that we convert it to z first of all. We say it's z greater than something. This probability is equal to 0.7253. Probability of z greater than something is 0.7253. And now we need to figure out what this value of z is. That corresponds to 50. All right. Now, the first thing we do, as usual, is figure out whether z is positive or negative. So what do we understand from this? This greater than sign is telling us area to the right of this value of z is 0.7253. 0.7253 is bigger than 0.5. So it's greater than 0.5. You compare with 0.5 to basically say whether it's bigger or smaller, because the total area is 1. So if it's bigger than 0.5, then it's bigger. Okay. So area towards right should be bigger than 0.5. Now, again, think of the normal distribution curve. This is how the curve looks like. Now, where do we place z here on this curve? Right or left? How do we decide if z is positive or negative? Remember, we have 0 in the middle. Now we are saying area towards right should be bigger than 0.5. If we had z here on the right side, the area to the right of this value is actually smaller than 0.5. So z can't be here. If z was on the negative side here, the area to the right of z in that case would be bigger than 0.5, and that's what we want. Area towards right should be bigger than 0.5. So the value of z is actually negative here. So keep this in mind. The value of z that we have here is a negative value. All right. Now, since z is a negative value, it's not the standard form. Remember, the standard form looks like this: z less than a positive number. This is the form that we need at the end. What we're given here is, we're given that the area to the right of this negative value z, how much is this? This area is 0.7253. So all of this region, this is 0.7253. You can write that here, 0.7253. That's this area. Now we can't use the table for this because it's not the standard form. What we do for this is we flip this area. Let's flip this. If we were to flip this, that would give us something like this. Z would come on the right side here, and we would get this area that is to the left of this positive value z. This area would also be the same. It's just a reflection of this previous curve. If we take z on this side to this side and consider the area to the left of that value, since the curve is symmetric, the area to the left of this positive value of z is also going to be the same. So probability of z to the left of the positive value of z is 0.7253. So for instance, if the value of z here was minus 1.4, and the area to the right of that was 0.7253, just as an example, then the area to the left of plus 1.4 would also be 0.7253. So that's what we're saying. If we consider the same magnitude of z on the positive side, the area to the left of that would be the same. All right. Now, this is the standard form, z less than a positive number. We can use the table to find this positive value of z. Let's use the table and find this value, 0.7253. Remember, table does not have negative values of z. So that's why we have to convert it to that form. Now, the probability that we were given there was, let's check that again. The probability is 0.7253. 0.7253. We need to find the corresponding value of z for this. 7253. We don't have 53 here, but we have this as the smaller value to that. Right? The next value is bigger than 0.753. So we take the value that's immediately smaller than that. What's the corresponding value of z that we get from this? 0.5 and 9. So z equals 0.59. But the probability that we were looking for was 0.7253. What we have found from the table is 0.7224. How much do we need to add to 0.7224 to get 0.7253? Let's find this difference. It's 29 at the end, 29 at the end. So now we see where 29 is here. 29 is going to be right in the middle of 27 and 31. Now, since it's exactly in the middle, we could use any one of these two values. We could either use 27 or 31 and see what corresponding value we have for that. So we could either choose this or this. That's our choice. Let's say if I take 27, that's giving me 8. So you could choose any one of these two. Let's choose 8. So we have z equal to 0.598. All right, that's the value of z. 0.598. But remember, this is the positive value of z. Z was actually supposed to be negative. So what you do is you say z is equal to minus 0.598. The actual value of z here is minus 5.598. And when you use the table now, you will be inputting, when you use the formula now, you will be inputting this value of z in the formula. The z is supposed to be minus 0.598. If you input plus 0.598, you'll be getting wrong answers. So keep this in mind. You should be inputting minus 0.598 in the formula. All right, so since the value of z was negative there. Let's take another example. Let's take one last example in this. Let's say we have probability of x less than 52. That was given to be, let's say, 0.352. Yes, you had something like this given. All right. Now let's find the value of z corresponding to this. How do we start? We first write this in terms of z. So it's z less than something that is equal to 0.352. And now we need to figure out whether this value is positive or negative, because we need to have the standard form for using the table, probability of z less than positive. If we don't have the standard form, we can't use the table. So how do we figure out whether z is positive or negative? We think of the curve. This is what the curve looks like. Now, there's a less than sign. That means we're talking about area to the left. Area towards left of this value of z, that should be 0.352. Is that bigger than 0.5 or smaller than 0.5? This is smaller than 0.5. So the area towards left should be smaller than 0.5. Where do you place z now? If you place z on the right side, the area to the left of this, if you place z on the positive side, the area to the left of this would be bigger than 0.5. And if you place z on the negative side here, the area to the left of this would be smaller than 0.5, and that's exactly what we want. The area to the left should be smaller than 0.5. So z is supposed to be negative here. The value of z is negative. And we know that this area here, this yellow region, how much is this? This is 0.352. This area is 0.352. That is what we are given. But the problem is it's not the standard form, right? The value is negative. So what do we do for this? We can first flip this, right? Let's flip this. If we flip this, we can say the area to the right of the positive value of z, so the corresponding positive number here, let's call this z plus. This area is also going to be the same. This area would also be 0.352, right? So the area to the right of this positive value is 0.352. But it's still not the standard form. We need the area to the left of positive value z. So if this area is 0.352, we can say the area to the left of this value of z, this is going to be 1 minus 0.352. So we can write this probability as z less than the positive value of z less than this value of z, that is equal to 1 minus 0.352. And see what that turns out to be. This would give you 0.648. And now we have the standard form. This is something that we can find, and this is something that we can find from the table. Okay, so now the probability is 0.648. Let's look for the corresponding value of z from the table. Now it's the standard form. Let's go to the table and figure out the corresponding value for z. 0.648, keep that in mind. The probability now is 0.648. Now remember, in the table, the probability values are given to 4 decimal places. So 648 means 6480. All right, let's look for this value. 0.6480. Well, fortunately, we have this exactly here. We have the exact value here. So that's 0.38. So the value of z that we get from this is 0.38. Okay. We go here. We say the positive value of z is coming out to be 0.38. However, z was actually supposed to be negative. So z equals minus 0.38. The actual value of z was negative. So the value of z that we get therefore is minus 0.38. Now we input this value in the formula for whatever you have to calculate. Z equals x minus mu over sigma. Input the value of z here, which is minus 0.38. And whatever is the unknown, then you can find that. You can figure that out using this equation. All right. This is how we use inverse normal. So we have to first convert it to z form. Once we have done that, we have to figure out whether the value of z is positive or negative, and then convert it to standard form, use the table to find the value of z, and then put that in the form. All right, so this is how inverse normal is going to work. Now, let me just summarize this that we've done until now. Let me see if I can find that somewhere here. Yeah, just copy this here. So this is how this inverse normal works. You have to do these steps. The problem would be that you'll have a probability given, and you'll have something missing from the data. You might have x missing, or mu missing, or sigma missing. You'll have to find those values that are missing. Okay, you'll have to find those unknowns. How do you start? You start by writing the given probability in terms of z first of all. It was initially in terms of x. You write that in terms of z first of all. And then you figure out whether z is positive or negative. Okay, that's the first thing you do. You look at the curve and figure out where you can place z, whether on the positive side or on the negative side. Once you figure that out, you convert it to standard form because that is what you need for the table. Okay, you convert it to standard form. Once you have done that, you find the corresponding value of z from the table and then assign appropriate sign. If it was positive, you keep it positive. If it was negative, you make it negative. Okay, so you have to assign appropriate sign to z, positive or negative, as we figured out in this first step. Once you've done that, you use this formula z equals x minus mu over sigma to find any unknowns that you have, which could be x, mu, or sigma. All right, this is how inverse normal works. This is known as inverse normal. The first thing that we did was simple normal, in which we have data given and we had to find the probability. For in that case, we just had to apply the formula, convert it to z, convert it to standard form, and then use the table to find the probability. That was the easier part. In inverse normal, you have to do all of this, and that's what we wanted to do today. Now let's finish with one quick example. Remember, we did question number 19 in our last class from the worksheet. We did question number 19 from the worksheet, sorry. Let's have a look at this. This was the question that we did in the last session. Let's complete that question. Let's do the second part of that before we end. All right, so we're looking at this question earlier, question number 19. We did this in the last session. Let's have a look at this again and try the second part of this now. The first part was simple normal. We did that in the last class. You can just copy that working here. This is what we did for the first part. Right? Now let's look at the second part of this question. Now in the second part, it says, in another city, so in the first part, we had the city Ottawa, for which we had to find some probability. In the second part, it says, in another city, the daily minimum temperature in degrees Celsius in January is a random variable with distribution n mu 40. So that means, let's actually just write that down here, n mu 40. What does it mean? Mu is unknown. We don't know the value of mu. Sigma square, however, is 40, which means sigma is square root of 40. All right. Now, we know that in this city, the probability that a randomly chosen day has the minimum temperature above 0 degrees Celsius is 0.8888. Given this, find the value of mu. So the variable is daily minimum temperature. Let's call this x. They are telling us the probability that the temperature is above 0 degrees Celsius is 0.8888. So if we write this in probability form, we can say probability of x greater than 0, the probability of x being greater than 0 is equal to 0.8888. That is what we are given. We need to find the value of mu from this. How do we start? we first convert it to something in terms of z. So it becomes z greater than something. We don't know what this value of z is. Remember, this is inverse normal. We have probability given. We need to find something missing from the data. So this is inverse normal, right? So we convert it to something in terms of z first of all. We say z greater than something is equal to 0.8888. And now we need to figure out whether this value is positive or negative. How do we do that? We do that using the normal distribution curve. Let me copy that here. Let's think of this curve. Okay. So we have area to the right side. All right. So we are saying area towards the right, that has to be greater than 0.5. Area towards the right should be greater than 0.5. Now, where do we place z? We would have to place it on this side. Why? Because we're talking about area to the right side. That should be greater. So if we place z on the negative side here, the area to the right of this value would be greater. All right. So z has to be here. So that means z is actually negative. So the value of z is negative. Keep this in mind. At the end, you have to put z as a negative value. All right. And we are given that this region, all of this area, this is equal to 0.8888. This is what this region is. All right, all of this region is 0.8888. Now, is this the standard form? It's not the standard form. For using the table, you need something in this form, z less than a positive number. It's not that standard form, so you can't use the table yet. So how do you convert it to standard form? You can say, let's flip this curve such that you have z on this side. So if you were to make z positive, the area to the left of that positive value of z would also be 0.88. So we can just flip this, right? We can say this is probability of z less than a positive value of z. That would also be 0.8888. So if we take this to the right and we consider the area to the left of that value, that is also equal to this. Now, this is the standard form. We can use the table for this, 0.8888. Let's find this value from the table. Let's see what the value of z turns out to be. Remember, we have probability given. We have to find the z value. Probability is 0.8888. Let's look for that. Well, we have this exact value here, 0.8888. So the z value therefore becomes 1.22. Okay, it's 1.22. Let's go back. The positive number z that we're getting from the table is 1.22. However, remember, z was actually supposed to be negative. So you say z is equal to minus 1.22. Now you input this value in the formula, z equals x minus mu over sigma. Z is minus 1.22, that equals x. In place of x, we input 0. Minus the mean. Mean of this distribution is unknown. We have to figure that out. Divided by the standard deviation, that was square root of 40. Just multiply square root of 40 on this side. You have a negative sign on both sides. It's going to get cancelled. And the mean is going to be 1.22 into square root of 40, which turns out to be, let's evaluate this, 1.22 into square root of 40. This gives us 7.72. And that is what we were looking for. Mean of this data was missing. This is how we can use inverse normal to find the mean. All right, so that's how inverse normal works. Now, in the next session, we will be doing some practice questions on this. All right, So on Monday, we will be doing practice questions on normal distribution on both simple normal and inverse normal. And on Tuesday, inshallah, we will do binomial to normal approximation. That's the last concept that we have left. And then on Wednesday, we could do some more practice before we wrap this topic up and our whole S1 paper as well. Okay, so that will be the end of S1. That's it for today. If you have any quick questions, you can let me know. Otherwise, we end it at this point. I'll see you again on Monday. Any quick questions?
Sir, I wanted to ask if you could share the notes of the checklist of like the concepts of all papers.
Yes, Iman, I remember that. It's going to require me to spend some time. I'll hopefully do that latest by tomorrow. Okay, inshallah.
Okay,
I'll try to do that.
thank you, sir.
Okay.
Love, sir.
Okay. Allah Hafiz.